How will we engineer the city of tomorrow to accommodate our physical requirements? How will we design our city to express the human quest for beauty, creativity, and perfection? This is Session 7, Engineering and Architecture, in a course titled Blueprint for Reconstruction, and that is an aspect of a larger view, evolution of consciousness theory. In this session, we move beyond the concept of tomorrow's city and look at the details of its construction, at the functional and aesthetic makeup of our city. In concept, we have a design that provides for individual freedom and mobility, and that accommodates the evolution of social structure to less collective and centrally administered forms. It is time to flesh out our plan. We begin with the building block of our city, that which in previous sessions we called the urban community. We want our urban community to be a vibrant place, but not one that is so crowded we feel cramped. How will we accommodate 50,000 people, or whatever number we ultimately come up with, on 1 square kilometer? We start with the bottom half of our urban community, the foundation structure. Every building has a foundation, and as in rural construction, it must be able to withstand any destructive forces we would expect it to be subjected to. In the future, military weapons and industrial accidents will not be the issues that they are today, but our cities and the foundations on which they rest must be able to weather fires, tornadoes, hurricanes, and earthquakes without damage or interruption of function. Like dams and other grand works of architecture, we must also engineer our foundation structures for a long working life, hundreds, even thousands of years. In our urban community, the limiting design factor is earth movement. As we know, the rough shape of the urban community is a circle a little more than 1 kilometer in diameter. We, however, cannot build a foundation structure this large and expect it to withstand an earthquake. Earthquake force travels in waves. As an earthquake wave moves through the ground, it would lift one part of the foundation and lower another, like when on a pond a wave passes through a lily pad. There is no practical way to reinforce a rigid structure 1 square kilometer in area against the stresses a severe earthquake would impose, so we must make our foundation structure flexible. The solution is to divide our 1 square kilometer circle into chunks or units, small and strong enough, and with enough space between them, so that when jiggled by an earthquake, they will not be damaged or bump into each other. As any engineer will tell you, the best place to build this, or any other type of structure, is on bedrock. Say that, at the site we have selected for our urban community, bedrock lies 18 meters, or about 60 feet, below the surface, and that we have excavated to that depth. Now, imagine that the independent units of our foundation structure extend from the bedrock to the surface. Also imagine that our structure was near the coast and subject to hurricanes and storm surges, and that we extended our independent foundation units up an additional 18 meters. If our building material is concrete reinforced with steel, carbon fiber, or other material with good tensile strength, we now have a foundation structure able to withstand fire, tornadoes, earthquakes, and a tropical hurricane. We also have a 12-story partially buried structure with a lot of room inside. The lowest levels of our structure would be a good place to put sewage tanks, 1 or more in each foundation unit. We will probably treat sewage and plants outside the urban community, but the urban community would need some ability to buffer sewage flows. Above the sewage level, we would put water tanks. We will probably purify water in an outside plant, but some storage in the urban community would be necessary. Further up, we would have power, communication, and heating and cooling facilities. Above that, and above the height of any storm surge, we would run the pipes and cables that link the foundation units, designing lines to withstand movement between units. We would also have a facility to route garbage out of the community and a facility to route goods into and out of the community. We now have a foundation structure with the mechanical systems to provide water, sewage, power, communications, air conditioning, and goods transport. Systems would be accessible for maintenance and replacement, and there would be room for redundancy. When a water tank needs cleaning, we will draw water from other tanks in other foundation structures or in other sections of our structure. Our foundation structure also gives us an easy way to route utilities. vertically to higher levels. We can think of the foundation structure as a standard component. We may vary the height and size of the foundation structure to accommodate the depth of bedrock or other site consideration, but its overall dimensions are fixed by engineering requirements and by human social and physical needs. Within the foundation structure, we can install and upgrade any number of mechanical systems, but there are only so many ways to build the structure itself. Construction involves engineering on a massive scale, but in a simple and repetitive way. The foundation structure may be a standard component, an exercise in engineering creativity, but its uniformity creates the situation where architectural expression can unfold. The foundation structure is the base on which we can build almost any arrangement of structures we can imagine. It is the platform on which we can over time perfect the urban community. Directly on the foundation structure, we will place levels that house our transit terminals. These levels will also house shops, theaters, classrooms, restaurants, and almost any business we can imagine, and that we can conduct in a densely populated urban environment. Shoemakers, clothing makers, furniture makers, healthcare providers. Higher up, we will have more levels filled with more shops, theaters, classrooms, restaurants, and businesses. We will mix schools with commercial activities. We will mix businesses with living spaces and recreational facilities. Our imagination knows no bounds. Above the sweeping expanses of our urban community's lower levels, grand towers will soar skyward. We will anchor these and other buildings to the independent units of our foundation structure. This allows the urban community as a whole to flex, and thus to absorb earth movement. As we walk the city, however, we will probably not be aware of its compartmentalization. We will bridge the relatively short distances between each of the foundation structure's units by pedestrian avenues and by levels of pedestrian avenues. Horizontally, transportation will be on foot. Vertically, transportation will be by stair, ramp, and escalator. Banks of elevators will service tall buildings. Whereas the design of the foundation structure is largely fixed, the design of the urban community will be flexible. On the foundation structure, we can build, tear down, and remodel for centuries to come, without affecting our community's structural and mechanical integrity. The same standards of beauty and functionality apply to our city's personal spaces, to our homes. Unlike today's cramped city apartments, under economics of fulfillment, we are not bound by cost and budget concerns, and can shape the living areas of the future in any way we imagine. Constructed in towers with windows and balconies that overlook the city, we will design spaces that are architecturally classic, architecturally modern, and everything in between. Because fire and maintenance are critical concerns, many homes will have marble walls and tile and granite floors. All will have the best workmanship and the best handcrafted cabinetry and furnishings our economics of fulfillment system can deliver. The building block of the future city is the urban community. It is the core component of the urban framework, our hometown. The urban community will support a diverse economy. The urban community will sustain more intimate levels of social organization. The urban community will be our place, our home, the geographical area where we will live, work, and feel we belong. We will have our circle of family, friends, and co-workers, in whatever form humankind's evolving social needs, and the expression of those needs will shape these relationships. The urban community will serve as the basis for a rural, urban, regional, national, and global social structure, the earth decollectivized. Just as our rural community promises the best of small-town life in the countryside, our urban community promises the best of urban life in the city. What will the city of tomorrow look like? Envision the city's foundation structures. Envision the city's shops, plazas, restaurants, walkways, and transit terminals. Envision the city's towers and their architecture. Envision the view from your tower home. Is the city of tomorrow a place where you would want to live? With our look at the architecture and engineering of tomorrow's city, we complete Session 7, in our course titled Blueprint for Reconstruction. How will we put our vision of urban and ecological reconstruction into place? Our course on the reconstruction of the Earth's urban and ecological infrastructure continues in Session 8, Implementation.